Hi everyone. Today we are going to discuss about the electric flux and Gauss law. What do you mean by electric flux? The electric flux denoted by phi E may be defined as is a measure of the net number of the electric field line passing through a surface. For example, there is an electric field, okay? Electric field lines are there. When a surface element is placed in this electric field and the area vector of that surface element is normal to the surface of plane, okay? So here if this is the surface placed here, okay, and the direction of the electric field and the surface of that area, they are normal each other. And the area vector, what will be the area vector? This will be the area vector drawn, okay, and this area vector will be perpendicular to the normal to the surface. And how many number of electric field? These all are field lines, electric field lines. The number of electric field lines crossing that surface area is given as the strength of that electric field. So what happens? This area element is slightly tilted and it makes an angle theta. For example, this area is slightly tilted like this, and now this is the area vector and it makes an angle theta with this electric field lines. When this area is tilted, so the number of electric field lines crossing that area will be less. Surface area, and this will be the area vector, and the area vector, the direction of the area vector and the electric field lines, they are same. And now this area is tilted slightly, and so that it makes, now this is the area vector, and when they are tilted it makes an angle with the electric field lines now. So now the number of electric field lines crossing that area will be less than this position, okay, and this number of electric field lines crossing the area element is proportional to the electric field and the area element delta S. And when this area element makes an angle theta with this electric field, then what happens? And this becomes E into delta S cos theta. If you talk in terms of the vector, the number of field lines crossing that area can be written as E into delta S cos theta is equal to E into delta S into unit vector. So that is equal to E into delta S, where delta S is equal to delta S into its unit vector N. And here this delta S is drawn normally to the surface area and in outward direction. On the basis of this discussion, now we come into the quantitative calculation of electric flux. Now we define the electric flux through a surface is delta phi E is equal to E into delta S. that is equal to E into delta S into N, that is equal to E into delta S cos theta. Thus, electric flux associated with an area element is proportional to the number of electric field lines cutting through that area element. Now, this equation can be generalized to calculate the electric flux through any given surface. And for doing this, we divide the area into small area elements and then sum together, or they add together the area element and the electric flux through an area element. We have this equation and we add them together, sum them together, and so that we can get the total electric flux through any given surface area. The total electric flux through a surface given any surface, that phi E is sum of a surface S E into delta S, that is equal to sum of S E into delta S into unit vector N. So that is equal to the sum of S E into delta S into cos theta. And in terms of integral, and this equation can be written as phi is equal to the closed integral S E into delta S, that is equal to closed integral of S E into delta S into N. So that is equal to closed integral of E into delta S cos theta. The electric flux phi E is expressed as the scalar quantities of the electric field and the area or the surface area S, and it is clear that the electric flux is a scalar quantity. The SI unit of electric flux is Newton Coulomb inverse meter square. Gauss law correlates with the electric flux through a surface. As per Gauss law, the total electric flux of an electric field through a closed surface is 1 by epsilon 0 times the net charge enclosed within the surface. Right, phi is equal to closed integral of S E into d S is equal to 1 by epsilon 0 into Q enclosed. These equations holds good when the charge is only enclosed within the surface and the charge is in vacuum. So let us consider a sphere of radius R, this is, and consider a small area element on this surface, on the sphere. The direction of area vector and the direction of electric field are same, and this sphere enclosed a charge at its center. As per Coulomb's law, the electric field at this point on a surface area is given and its magnitude is E is equal to 1 by 4 pi epsilon 0 into Q divided by R square, and this E is directed radially outward the sphere, and the area vector and the electric field both are in the same direction. The electric flux through this area element phi E is equal to we know that E into delta S can be written as E, what is E? 1 by 4 pi epsilon 0 into Q divided by R square into delta S. So that is equal to 1 into Q can be written as Q divided by 4 pi epsilon 0 into R square into delta S. Delta phi, that means electric flux through the small area element S, delta S. Now, what will be the total electric flux through the given surface? And the total electric flux through the given surface can be written as, the total electric flux will be phi is equal to sum of this total area element. Okay, so we have taken a small area element, and the magnitude of that electric flux through that small area element is equal to Q divided by 4 pi epsilon 0 into R square into delta S. Then what will be the total electric flux through the whole surface area will be sum of Q divided by 4 pi epsilon 0 into R square into delta S, that is equal to Q divided by 4 pi epsilon 0 into R square, the sum of the total surface area, that is equal to Q divided by 4 pi epsilon 0 into R square into the sum of the total small area element, that is the total surface area of the sphere. So that is equal to Q divided by 4 pi epsilon 0 into R square, and the total surface area is equal to into 4 pi R square. So R square 4 pi will be cancelled, and what will remain there? Q divided by epsilon 0. So the Gauss law is satisfied. So thus it is obviously clear that the Gauss law is based on the Coulomb's law. Some important points regarding this Gauss law are: Gauss law is true only when the surface is closed, irrespective of its size and shape. Q enclosed given in this expression is the sum of the all charges inside the closed surface. The total electric flux is 0. Either no charge is enclosed in the surface, or when the algebraic sum of all the charges is 0. The closed surface we have chosen here, and this surface is called as Gaussian surface, and one may can choose any Gaussian surface and apply Gauss law.